All right, we've been talking about reverse engineering, and we've gotten to the point where we want to talk about functional analysis, that part of the reverse engineering process. We got a general sense by now what reverse engineering is, but we haven't really had a clear definition of it yet, and so I want to provide you with that. This is, I think, a pretty good definition. It's the process of taking something apart and analyzing its workings in detail. And then that second part's important too. It's usually with the intention of understanding the structure, the function, the operation. In other words, if I look at a product, if I look at this thing, I want to know how it works and why it works and what the purpose of it is. And we're going to look at really 4 different reasons of why we might want to do that. Why would we want to reverse engineer something? Here are those 4 reasons. Documentation, discovery, investigation, and product improvement. And I should let you know that in this presentation, if you have the link to the actual Google Slides that I'm going through here, I would suggest that you take a look at that, because there's going to be some extra notes underneath some of these slides that I'm not going to go through with all of these. Okay, so to keep that in mind, you might want to go back to that. We're going to look at each 4 of these individually now. So let's start with documentation. You might have some type of product that doesn't have any kind of existing documentation. It's been around for so long, it's worked for so long that somewhere along the line, with people changing in and out of jobs that work with a particular product, that documentation got lost. And so if that product is still in existence and still being used, the company that's doing this may want to produce some documentation. In order to do that, they need to reverse engineer the product itself. Okay. The other aspect to that is interoperability, which just means I've got this old product. We now have this new product that we know a lot about. We want them to talk to each other. But we need to understand this product really well first, so that those products, the old and the new, can talk to each other. Okay, maintenance would be another reason that we'd want to produce some documentation about a certain product, and therefore we have to go through this process of reverse engineering and understanding what it's all about before we can do that. Okay, so that's the first reason you might want to reverse engineer something. The second reason is just discovery. Okay, so if there's certain things out there that the scientific world wants to know about, we might need to actually take current data or current things that we know about and basically tear them apart. If you know anything about the Human Genome Project, you would recognize that this is an example where we're taking current data and basically working our way backwards. If you don't know much about that, I would suggest that you check into it. Another great example of discovery, and again, we're still just on the second reason why we would reverse engineer something, is the military. If you think about past wars, this plane is shot down. That plane is shot down on enemy territory. Guess what? Those enemies are going to take a look at that plane and see exactly what's working well and try to see if they can recreate that type of plane or that type of machinery or whatever it ends up being, so that they can make something just as good, if not better. Okay, so we've talked about documentation and now discovery. The third reason why we might need to reverse engineer something is for the sake of investigation. If something happened, typically this is going to be kind of a negative thing. A bridge collapses. Who's responsible for that? Well, you have to look at how the bridge was engineered to see if it was the fault of the builders that built it, or if it was just the circumstances that caused something to collapse. Okay, so an investigation might be a reason that you want to reverse engineer something. Finally, and this is probably more so a real-world application that you guys are used to seeing, we might want to reverse engineer something for the sake of improving or redesigning a product. And you see all those different kind of subcategories to that. If you want to take something and make it more efficient, or make it more reliable, or reduce the cost of it, all those are reasons that you might want to take a look at a product and say, how was this product built so that we can do it better? Great example of that with phones, right? Apple versus Samsung. If you think that Apple is not looking at the Samsung phone and saying, what are they doing well so that we can take it and make it better than that, and Samsung is doing the exact same thing, you'd be kidding yourself, right? They're constantly looking at each other's product, reverse engineering it and seeing how they could do it better without breaking any patent laws. Okay, so those are really the 4 reasons we would reverse engineer something: documentation, discovery, investigation, and then product improvement. Okay, if we're going to reverse engineer something, we need some tools to do that. We need tools to take it apart and fully analyze it. And you see a bunch of these here. Some of them you're familiar with, especially the caliper. Micrometers you might be familiar with. I do have a 3D laser here. I've got some pictures of those and what that might look like. We're hoping to get one of these at Shoreland sometime sooner or later. A 3D scanner takes some kind of thing, this little statue that they've got on here, and it's this circular platform that rotates. And so as that platform rotates and therefore rotates the statue, it's got this camera that is scanning it and taking a whole bunch of different pictures of this, so that it can take that entire statue and basically throw it into a CAD model, so that what you've got there can be recreated virtually. They've even got some, these are a little bit more expensive, but the same kind of thing where it's a handheld one, so you could take a larger item. If I wanted to 3D scan a desk, I could move myself around that desk and it would be taking a picture of all the different angles around that desk or whatever it is, so that I can put it into some kind of CAD model. So a bunch of different types of tools that you can use. Some of them are becoming more and more proficient in analyzing a certain object or product. Okay, so we've talked about this a little bit too, these stages of reverse engineering. So we're going past why we would want to, and now how do we actually go about doing that. We've already looked at the visual analysis, where we're taking a look at some of the visual elements and principles and seeing how they mesh. But now we want to talk more about that second stage, which is the functional analysis. Okay, so that second stage of functional analysis means what function does this product perform, and we're going to take a look at that in kind of 3 different layers, 3 different levels. And the first thing is just to understand whatever product I'm trying to reverse engineer, what's its purpose, what's it trying to accomplish. And after we understand that, then we can take a look at the product and the different parts of the product to kind of guess how that helps it meet its purpose. And then finally, we're going to talk about the inputs and the outputs. We're going to use something called a black box system to identify those. We'll look at an electric toothbrush as an example. So that first thing that we want to do as part of the functional analysis is to look at the purpose. Well, what does a toothbrush do? It cleans teeth, it cleans gums for the sake of health, to prevent tooth and gum decay. Now, we know water has to be used and some kind of paste has to be used as well. That's part of it, but the purpose itself is to clean teeth. Okay, so now that we understand the purpose, the next thing would be to look at the different aspects of that product, the toothbrush itself. A lot of times this will come with an annotated sketch, so that we can identify we've got this part, this part, this part. In the case of a toothbrush, we've got the head with the different bristles on it. That head with an electric toothbrush rotates. You've got the grip on the body of the toothbrush that turns the motors inside. Okay, you could take this apart and annotate different parts within that toothbrush as well. Okay, a hypothesis is then devised to describe the sequential operations or functions. So we could say, based on what I see and based on what I know the purpose of this toothbrush is, I think what you do is you would use your thumb to push the grip up, which would turn the motors inside, which would spin the head, which essentially spins the bristles, and now you can clean. Okay, so that's really the second part of this functional analysis, recognizing the different parts that make up the function. And then finally, that third part of functional analysis is to understand the inputs and the outputs. And we use this thing called a black box system in order to do that. Okay? The black box system represents the things that you start with, the inputs, and then what the product does with those inputs so that you can get specific outputs. In the case of this toothbrush, if you think about what are we starting with, we really have a hand motion as you move your hand back and forth to move the toothbrush itself across your teeth. You've got the toothpaste, you've got water, and you've got energy. All of those things are at the beginning before the product begins to actually function to meet its purpose. What do you get because of that? Well, when you turn the battery on, that energy creates a sound. It creates heat, a little bit of friction. You're getting the leftover toothpaste, the waste there, and you get clean teeth as a result. So it's meeting its function. It's meeting its purpose. Okay, all of those are different parts or different outputs that we get because of the different inputs of that product. So altogether, that's what functional analysis is about. You could use this black box system on basically any type of product that you're trying to analyze. So again, just as a review, we had 4 different ways that, or 4 different reasons we would use reverse engineering: documentation, discovery, investigation, and then product improvement. The second stage of reverse engineering, which is functional analysis, is really broken down into 3 parts. We said first we want to identify the purpose, then we want to look at the specific parts of the object to see what their function would be, and then we look at the black box system to analyze inputs and outputs. That is functional analysis of reverse engineering.